And welcome back. So at this point, we will be working on a second example and how to apply the first law of thermodynamics, also known as the law of conservation of energy. So problem states that the work done on a system is 450 joules while the internal energy decreases by 260 joules. How much heat is added or removed from the system? So is it added or removed? So how much heat? So we are solving for Q. Now, first thing, as I mentioned in the first example, first advice is to write down the equation corresponding to the first law of thermodynamics, which states that the change in internal energy delta U is equivalent to the sum of the heat Q plus the work done. Okay, work done or work done by or into the system, and Q is added or removed from the system. Second step is to draw a diagram where you have an object or a system where we have a movable cover filled with gas where the dots represents the molecules that is trapped inside the cylinder, and according to our example, the problem example, it says that done on a system, so it means the work is being done on the system. So if you provide work on the system, so it means work is towards the system. So in our case, we have 450 joules and it's not moving away. Okay, again, it's not negative or positive because it's to the left or right, but instead, if it's moving away or moving into the system. So since it is moving into the system, so work done is positive, 450 joules. Now, another information that is provided is that there is a decrease in internal energy. So delta U, or the change, is not positive, but instead it's negative because there's a decrease, not increase. So the word is decrease. If it's increased, then it's positive. If it's decreased, it's negative. Straightforward. So that's negative 260 joules as our change in internal energy. Now we want to figure out if it's either added or subtracted. Okay, so is heat added or removed into the system? Okay, so Q. What is our Q? Is it added or removed? Okay. Are we adding or removing heat? So why don't we apply the information that is provided to us into the equation? So we all know that we have a negative 260 joule as our change in internal energy. Heat is something that you or we need to solve for, plus the amount of work done, and in our case that is positive 450. So positive 450 and 260. So in order to get rid of 450 on this side and move it to the other side, let's subtract negative 450 on both sides of the equation. So this will give us 450. So the sum right here will be 0. So now we have a value of negative 0, 1, 2, 4, that's 6, and then plus 1, so that's 710 Q, or we can just basically say that there is a negative 710 joules of heat that is being calculated in this equation. So it means that there is a negative 710 joules, or it means that heat is being released from the system at a magnitude of 710 joules. Hope it will help you in your own steps on with your own problem on solving word problems related to Newton's or first law of thermodynamics, also known as the law of conservation of energy.